Okay, so our sixth has to do with radicals. So we'll start off pretty basic here with just some square roots, and then we're going to talk about cube roots and nth roots. All right, so the square root of a squared is absolute value of a. So if we're doing a square root, or we'll see in a minute, an even root, we're going to have a positive number. So we're not talking about imaginaries. You don't have to worry about plus or minus when we're simplifying. Now, later on in the next chapter, I don't know, the chapter 1 or 2, when we're solving using radicals, we'll be doing plus or minus. So, the radical's already drawn in again, so I'm only looking for just the positive. What the square root of 100 is 10, and the square root of x squared is x. Okay, so the square root of 100x squared is 10x, not radical 10x. You've already done the square root, so you don't write the square root sign again. Okay? So when you multiply under a radical, you can separate those. So like I could have separated 100x squared as 100 times x squared. So I could have done the square root of 100 times the square root of x squared. But when you add and subtract, you cannot separate. Those are stuck together. So really the most that I could do is just try to factor in here and see where that gets me. So I need numbers that multiply to be positive 4 and add to be negative 4. Negative 2 and negative 2. Okay. Well, negative x minus 2x minus 2 can be written as x minus 2 squared. And now I can do the square root. The square root of x minus 2 squared is x minus 2. No radical because you've already done the square root. Questions about that? Okay. Talk about cube roots. All right, so cube root can be positive or negative. So it's whatever a is. So if a is positive and you do the cube root, then it stays positive. If it's negative, then it stays negative. So I'm going to go ahead and separate these, the numbers and the variables. I'm going to go ahead and separate them. Since I'm multiplying, I can separate. So cube root of negative 27 times the cube root of x cubed times the cube root of y. Okay, what's the cube root of negative 27? Negative 3. Good. What's the cube root of x cubed? X. What's the cube root of y? It just stays the cube root of y. You can't simplify that one. Okay? Questions about that one? All right, so for the nth root, we have a couple different options. So nth root, meaning n could be any number. Okay, so when n is even, then, like square roots, it's the absolute value of A. I'm only getting positive roots here, positive numbers. When n is odd, so cube root, fifth root, seventh root, it can be positive or negative just depending on what A is. Alright, so let's look at this example. So I'm doing the square root. Remember, if there's not a number here, it's assumed that it's square root, there's a 2. So the square root of x to the 4th. Alright, so I'm thinking about square root of x to the 4th. So what times itself is x to the 4th? X squared. Okay. X squared times x squared is x to the 4th. So the square root of x to the 4th is x squared. You think of it like that. X squared squared. Okay. We're not going to rationalize denominators today. We will do that tomorrow. But I can simplify this denominator. Okay. So what is the 4th root of 16? It's 2. So in your calculators, in the graphing calculators under math, there's this button with the x here for the root. So you have to type in the 4 first, then you hit this button, and then you hit 16. Okay, what's the 4th root of x to the 4th? X. Good. Okay, questions about those? All right, now we're going to talk about rational exponents. So writing your roots as exponents. When you write a root as an exponent, it becomes a fraction. So the nth root of A is A to the 1 over n. As long as it's a real number. That's what this this part says here. Is that we're just going to be talking about real numbers. If you have the nth root of A to the n, then first of all you could write the exponent, the n, on the inside or the outside. And your root still is the denominator of the fraction. So something that your Algebra 2 teachers might have told you when you were writing these to help you remember, the root goes on the denominator, so roots grow in the ground, so it goes on the bottom of the fraction. If you're having trouble rewriting those. Okay, so sometimes we want to change from exponent form to radical form, and then or vice versa to help us simplify. So is this possible to just type in your calculator? Sure. You got to make sure you type it in correctly. You have to use parentheses around your exponent. But the point of this is to practice writing it here with the roots, so that's what we're going to do. Okay, so it's easier to do the root part first, because if you're working these without a calculator, you want the smaller the numbers, the easier it is to work with. So you do the root first and then the exponent. So what root do I have here? Good. I have the square root of 81 over 16, and I'm taking all that to the negative third power. Okay? So when you square root a fraction, or you do any root of a fraction, you do the numerator and the denominator. So what's the square root of 81? What's the square root of 16? 4. And then I'm taking that to the negative third power. So I'm going to distribute this negative 3 to both the 9 and the negative 4. So negative exponents do not give me negative numbers, remember. What do negative exponents do? It does what? Yeah, it makes it move. So the 9 has to move and the 4 has to move. So then I get 4 cubed over 9 cubed. Four cubed is 64, and 9 cubed is 729. 4 over 9 didn't reduce, so 4 cubed over 9 cubed wouldn't reduce either. Okay? Yes. Well, you could, by subtracting, well, if they were the same base, you would subtract exponents. So if this were like 3 cubed over 9 cubed, you're not going to just reduce to like 1/3. So I would go ahead and do them first, but then reduce them. 27 over 729 would reduce. Well, and actually you could reduce because that's the same thing as this. So you could do 1/3 to the third power. You could do that. But you probably would have reduced back here or even inside the radical too, maybe. So if you can reduce, reduce. Okay, so I'm writing this in radical form, so what root do I have? 3, and what's the exponent? 1. So I'm just doing the cube root of 729. Well, I should know that because I just figured that out for the last problem. So the cube root of 729 is 9. Good. Okay, the fourth root of 256, so it wants us to write it in exponent form. So that's 256, and then what's the exponent? 1/4. So you can type it in your calculator either way. You could do the fourth root like this, or you could do 256 to the 1/4 power. Be careful though, if you do the exponent, make sure that that whole fraction is in the exponent. In the graphing calculators, if you use the caret key, then you have to use the parentheses around the 1/4. Okay, so what is the fourth root of 256? 4. Okay. Questions about this? Right, I'll get some more examples. root part first. So what's the root? Good. So the root is 3. And then what's the exponent? 2. Okay. I'm going to go ahead and separate these. So I have the cube root of negative 27 e to the 6 over the cube root of 8 cubed and all of that squared. Okay, so in the numerator, the cube root of negative 27 is negative 3. Okay, what about the cube root of p to the 6? It is p squared. If that's something that you don't understand or you can't figure out, then you might have to kind of write this out and think about it a little bit. All right, so p to the 6 right? And you're doing cube roots, so you have your groups of 3, and there's 2 groups of 3, so p squared. Or you could think of it like this with rational exponents. So my exponent is 6, my root is 3, so you can think of it like this, 6 over 3, which is 2. Okay? So if you have to work that out to the side or write that out, that's fine. Do what you need to do to get your right answer. Let me know if you need help. Okay, what's the cube root of 8? 2. What's the cube root of cubed? And squared. Okay. Now I have to distribute my exponent. The negative 3 is inside the parentheses. The negative 3 is being squared. So when you square negative 3, we get positive 9. Positive 9. Okay, and then p squared squared, e to the 4. Okay, 2 squared, and then q squared, q squared. Nothing reduces. Any questions about this one? Okay, let's go back up to this example. Okay, so I'm going to do the square roots of negative 49 over 36, and I'm taking that to the negative 3rd power. So I'm doing the square root of negative 49 over the square root of 36. What is the square root of negative 49? No. Technically, the answer is 7i, but we're not doing imaginary numbers. So if you have an even root, so 2, a 4, a 6, and a negative number inside, then that's going to give you an imaginary number. So we're not dealing with imaginary, so you can stop and say that it's not real, or you could write unreal. You could write imaginary. It's not really no solution, because there is a solution, it's just not real. I'm not as picky about this vocab as I would be with the word undefined. Like, for an undefined answer, that's the only word that works. For here, imaginary, not real, unreal, something like that. Okay? All right, this is talking about multiplying and dividing. So we already talked about this. When you multiply inside a radical, you can break it apart. And you can put them together when they have the same root. Same thing with dividing. You can break them apart or put them back together as long as their roots are the same. Sometimes it's better to put them together. Sometimes it's better to break them apart. If I look at this problem here, this first one, I see, okay, 18 is not a perfect square, 2 is not a perfect square. But 18 divided by 2 is a perfect square. So putting these together is going to be the easiest thing. So since it's square root over square root, I can do the square root of the whole thing. And 18 divided by 2 is 9. And then what about x cubed over x? That's x squared. Good. Remember, if it's a common base, you subtract your exponents. And now, this is pretty easy. The square root of 9x squared is 3x. Good. Okay. Over here, yes, you could do 20 divided by 4. You could do 20 divided by 4 and get 5. But I see that I already have a perfect square in the denominator, so I'm going to separate these. And either way you do this, you're going to end up with the same answer. So if you would have divided, you'd still get the same answer. But I notice I have a perfect square for x squared, so I'm going to go ahead and separate those. We'll talk about the 20 in just a minute, so I'm going to leave it as 20. What about the square root of 4x squared? 2x. Oh, sorry, that's still square root 20. Okay, so the bottom is simplified. Now 20 is not a perfect square, but it has a perfect square factor. So you started learning how to simplify these in Algebra 1, you did it again in Algebra 2, maybe even a little bit of geometry. So I'm going to go pretty quick through this. If this is something that you are going to need help with, let me know, or go practice some at home. Okay, so what is the perfect square that goes into 20? 4. And you always want the biggest one, but with 20, that's the only one that does go in there. And 20 can be written as 4 times 5. I wouldn't write 20 as 10 times 2 because neither one of those are perfect squares. So then I can separate my 4 and my 5. And so the square root of 4 is 2, so 2 comes out of the radical, and you have the square root of 5 over 2x. So square root of 20 simplifies to 2 square root of 5. Okay? Any other time we have to do this, I will go pretty quickly through. I maybe will write this step and go here. But sometimes we'll get to even where we'll just go here to here. Okay? Well, I'll talk through it, but I might not write every step down. I have one other thing I can do. I can cancel my 2's. So I get the square root of 5 over x, which is what you would have gotten if you divided. You would have 5 over x squared. Any questions about the simplifying part? Okay, a couple more to look at. Watching the time here. Okay, so what I have is the square root of the fourth root of a. So in radical form, there's nothing really that we can do. Let's change it to exponent form, and we can at least combine and get it down to one radical. Okay, so this is the square root, so it's the same thing as this, right? The square root is the same thing as the 1/2 exponent. Let me write the fourth root of a as an exponent. So that would be a to the 1/4. So a to the 1/4 to the 1/2. I can combine these exponents. What operation would I use? Multiplication. You have power to a power is multiplying exponents. So what's 1/4 times 1/2? It is 1/8. And I'll put it back in radical form since that's how it started. So that's the 8th root of a. So 8th root of a looks a lot better than the square root of the 4th root of a. Okay, let's look at this one. So square root over cube root. You can't combine under one radical because they're different roots. So let's do what we did here and change them from radical form to exponent form. So on the top, that's 6 to the 1/2. And on the bottom, that's 6 to the 1/3. I have a common base that I'm dividing. So what can I do with my exponents? Subtract. So 1/2 minus 1/3. What is 1/2 minus 1/3? What is 3/6 minus 2/6? 1/6. Okay, so 6 to the 1/6. I can rewrite that and in radical form as the 6th root of 6. Questions about that? Okay, we'll finish this one up tomorrow.